Welcome to our next lesson on solving trig equations. So in the previous lessons, we were trying to remember the values of the unit circle and trying to remember them in different ways. Now we're going to apply that to solve actual equations. And whenever we use the unit circle values, this is a non-calculator question, and you do need to remember the values that I told you to remember in the previous videos to help you solve for these equations. So here's the first example. If you look at the format of our trig equation, you can see that we're going to get a trig function, usually sine x, tan x, or cos x, and then some terms around that. What we want to do, just like any other equations, we want to isolate our x. In this case, I'm going to isolate sine x first, and then eventually I will get to x. So I'm just going to rearrange this equation then, so I can get sine x is equal to something. And in order to get that, I'm going to minus 2 on both sides. So 3 minus 2 is just 1. Now we have an equation that says sine x is equal to 1. This should look semi-familiar. We tried to solve for stuff like this in the previous lesson. And 1 is a point, y-coordinate, on the unit circle. And it would be located over here as a point of 0, 1. Remember that sine is in the y value on our unit circle. So this occurs at sine 90 degrees to get 1. So this means that x is equal to 90 degrees because 90 degrees is located up here. So if you don't remember this, then I want you to refer back to page 13 when we first did this. And if you look back at page 13, if we looked at the coordinate at 90 degrees, we're going to get cos 90 degrees, sine 90 degrees at that unit circle point, which is 0, 1. This is what you would find on page 13. Moving on to example 2, I need you to do a correction on this example. I want you to put a minus 3 instead of a plus 3, and then we're going to go ahead and solve for this equation. So just like example 1, I do want to get tan x by itself. Right now we have tan squared x minus 3 is equal to 0. So I'm going to add 3 on both sides as my first step in isolating tan x. And then in order to get rid of our squared, I'm going to square root both sides. So then we're left with tan x is equal to plus or minus root 3. So remember, when you square root both sides, you are going to get a plus or minus, which means that this plus or minus indicates that we're looking for solutions in all quadrants. So we're looking for whenever tan is positive and negative, and this occurs in all 4 quadrants. Now I want to find the exact value part, and I'm going to use our root 3, 2, and 1 triangle. So I'm going to go ahead and draw this. Again, hopefully by now you should have this memorized. So that's our triangle, and looking for the angle where we would get root 3 over 1, which is the same thing as root 3. This occurs at 60 degrees because that's opposite over adjacent. That's root 3 over 1. So our reference angle then is going to be 60 degrees according to this triangle. Now we're going to find our angles in quadrants 1, quadrant 2, quadrant 3, and in quadrant 4, because that plus or minus we found in step 1 indicates you to find an angle in all 4 quadrants. So 60 degrees is already in quadrant 1. If I want to find an angle in quadrant 2, it's going to be 180 minus 60, which is 120. To get an angle in quadrant 3, that's 180 plus 60, which is 240. And then lastly, to get an angle in quadrant 4, it'd be 360 minus 60, which is 300. And that is our answer. We have an angle in quadrant 1, 2, 3, and 4. And if you looked at the domain in the original question, we were looking for an answer between 0 to 360 degrees. And if you check your work, all 4 angles are in that domain. Moving on to the next example, example 3. In this case, we see that we have 2 terms with a trig function in it. And whenever you see that, we are going to factor. And I'm going to factor a cos x out. So then I'm left with 2 cos x minus root 3. If this confuses you, try to replace this cos x with some other variable. Let's say z. And then try factoring that, and then replace the z back with the cos x. Because if I try to factor this, I'm going to get 2z minus root 3, and then put the cos x back in. And if you make that comparison, that's exactly the same thing as what we have here. So that's an option if you tend to get confused by factoring with a trig equation in it, or a trig function in it. Okay, so after we've done that, remember this was equal to 0. We are going to solve for 2 parts of it, and we're going to split it into 2. So I'm going to look at the scenario when cos x is equal to 0, and I'm going to look at the scenario when 2 cos x minus root 3 is equal to 0. So I'm kind of splitting it in that way. So I'm going to solve for both. We can work with cos x equals 0 first. So to figure this one out, I'm going to have to draw a little bit of my unit circle, and I'm looking for whenever our x value in the unit circle is equal to 0. So that occurs here at 0, 1, and also down here at 0, negative 1. So this is 90 degrees, and this is 270 degrees. And remember that cos is in the first coordinate of our unit circle. So that means x is equal to 90 degrees, and x is equal to 270 degrees. And then we're going to look at the other side here. And now this part looks exactly like example 1, in that I want to isolate my cos x and try to solve for that. So I'm moving this around. I'm going to add root 3 to both sides and then divide both sides by 2. So I'm looking for when cos x is equal to root 3 over 2. This is our 60-30 triangle. And I'm looking for an angle that would give me root 3 over 2 using cos. So that's adjacent over hypotenuse. If we look at angle 30 degrees, my adjacent would be root 3, and then my hypotenuse is 2. So my reference angle then is going to be 30 degrees. Take a note that this is positive, which means that we're looking at quadrant 1 and quadrant 4, because that is where cos is positive. So our angle from quadrant 1 is just 30 degrees, and the angle in quadrant 4 would be 360 minus 30, which is 330. Now, I am going to state all of our answers from both of them, but we again need to check our domain. So for this particular question, we're looking for angles from 0 to 180 degrees. So that means I need to discard some solutions that don't fit that domain. And 270 doesn't fit that domain, and 330 doesn't fit that domain. So our only answer is going to be 90 degrees and 30 degrees. Now your domain will change depending on the question. So if this question says 0 degrees to 360, then you do need to include all 4 angles. But in this particular question, their domain is restricted. So just be aware of the restriction of domains. Our last example here, you have sine squared x minus sine x equals to 2. Just like in example 3, whenever you see a squared and then another trig term, you do need to factor. But because we have a 2 instead of a 0, I need to factor it a little bit differently than before. So in this case, I'm going to move everything to one side and then factor it. And the way we're going to do this is like how we would factor before when we were given a trinomial. We're going to have 2 sets of brackets like that. If this again confuses you, you can always write this as a different variable on the side and replace sine x with something like z and then factor it this way. So factors of 2 are 2 and 1, and we need a negative 2 and a positive 1 to achieve a negative 1 for our middle term, and then our variable is z. So that's how we would factor it from before, and then you replace that z back with sine x. So you have sine x minus 2 and sine x plus 1. If you can factor this without changing your variable to z, then that's completely fine. I'm just showing you a different way just in case you do need that extra support. Our second step is exactly like what we did in example 3 as our second step, where we are going to separate our factored form. So I'm looking at sine x minus 2 is equal to 0, and I'm also going to look at sine x plus 1 is equal to 0, and then solve for both. If I rearrange and solve for sine x by adding 2 on both sides, we can get sine x equal to 2. When we have a number bigger than 1 for sine x, we know that it's going to be undefined, that we can't find an x to satisfy this. So we just have no solution on this side. On the other side, I'm going to subtract 1 on both sides to get sine x is equal to negative 1. This is going to be a point on the unit circle we're going to look at. Remember that sine x is the y coordinate on the unit circle, and this occurs at 270 degrees. So x is equal to 270 degrees, and this was our only answer, as x is equal to 270, and that's it.